Now we're moving on to electrons, starting in our final review with question 60. Electrons and electron configuration. Number 60, what is the energy of a photon that has a frequency of 2.4 times 10 to the 11th hertz? If you remember, photons are produced when light comes in and hits an electron and it jumps out to a higher energy level. When it falls back, it releases that energy, and that energy is the photon. The photon travels at the speed of light, which we call c, 3 times 10 to the 8th meters per second. And the photon has both energy and a wavelength, which are inverse to each other. So if we take the speed of light and set that equal to our wavelength times our frequency, we can calculate one if we know the other. All right, and we happen to know frequency. Frequency is just the number of times it's waving back and forth. The units are per second. So we're going to take 3 times 10 to the 8th meters per second. Set that to equal the wavelength times 2.4 times 10 to the 11th 1 over seconds. Now we just need to solve for wavelength. If we divide both sides by our frequency, we'll get an answer. All right, our relationship here, speed equals frequency times wavelength. If you stop and think, velocity is the same as speed. Speed of light is always going to be 3.18, so the velocity never changes. It stays the same. As the frequency increases, it's going to wave more often, which means its wavelength is going to get shorter. And as the wave is waving more and more, that takes more energy, so our wavelength will increase. Our energy, will increase. Okay? Once again, speed it's proportional to frequency and wavelength, which are indirect. So if this is our wavelength, and if we begin to wave more frequently, then our wavelength gets shorter and our frequency increases. It takes more energy to increase that frequency, therefore the energy will increase. Number 63. An electron in a hydrogen atom has a transition from N4 to N2. All right, so N4 means level 4 to level 2. So it's going towards the nucleus. Does that mean it's gaining energy or releasing energy? Well, hopefully you remember what I just drew up here and then erased, that as the energy comes in, it excites the electron, it jumps out, and when he falls, he releases energy. Since he's going back towards the middle, he's going to be releasing energy. Now, does that mean he's absorbed radiation? No, he has not absorbed radiation. If he absorbed radiation, he would have gained energy. Has he kept the same energy? No, he has not. So the answer we're looking for here is release energy. We say that the energy that the electrons gain and release when they jump between shells is a quanta of energy. Quanta is an amount. And the man who came up with this is Max Planck. That's where we get Planck's constant from, which is what we use to calculate energy. Now, quantum physics refers to ways to identify the electrons. And in class we talked about it being in the hotel, the Aufbau Hotel, figuring out a way to come up with a code to designate different electrons so that pizza could be successfully delivered to them. When we talk about the 4 quantum numbers, the first number is the N number, which is the energy level or floor in the hotel. The L number indicates the room type or the shape of the orbital. And when we're talking about L, if L is equal to 0, it's an S orbital. When L is equal to 1, it's P. If L is equal to 2, it's D. And when L is equal to 3, it's F. ML refers to the room number. An S orbital only has one room, so it's only going to have a 0. A P orbital can have 3 rooms, so it has numbers from -1 to +1. A D orbital has 5 rooms, and those numbers go from -2 to +2. An F orbital would have 7, -3, 2, -1, 0, 1, 2, 3. The MS number refers to the spin. If they are spinning up, we say it is a +1/2, and if it's spinning the opposite direction, we say it's -1/2. So, energy level, and then the orbital shape, then which particular orbital it is, and then finally the +1/2 or -1/2 based on the spin. So it says, which of the following sets of quantum numbers is not possible? All right, so the first number is 1001/2. 1 means first floor. 0 means, the next one means an S orbital, which we have. The room number of S orbitals is 0, and it's a +1/2. So that electron would be there. Our second one, 401 -1/2. 1, 2, 3, 4. We're still talking about an S orbital, but there would be no room number 1 in an S orbital. So this one cannot exist. The third one, 3, 3, -2, and then 1/2. Was it negative? I've already forgotten. Yes. No, +1/2. So we'll start on the third level. And 3, the second letter, the D level, refers to 0 is an S, 1 is a P, 2 is a D. So this would be an F orbital. And there are no 3 F orbitals. So this guy cannot exist. The next one, 2, 1, 0, 1/2. We'll start in the second level. D equals 0 is S, D equals 1 is P, so it's one of these rooms. And we would be -1, 0, 1. So our electron would fit right here. The next one, 3, 2, -3, and 1/2. Third level, D equals 0 is S, D equals 1 is P, D equals 2 is D. But we would not have a -3 room. We would only go to -2. So this guy cannot exist. Finally, 3, 0, 0, -1/2. 3, third floor, 0, the S orbital. Its room number would be 0, and -1/2, he would be spinning like that. So, that one cannot exist, that one cannot exist, And this guy cannot exist. Number 67, electron configuration for an ion. Well, let's do cobalt first. Let's go 68 first, and then we'll do 67. Cobalt is element, and I gotta look it up. Sorry, I don't have that number memorized. All right, cobalt has an atomic number of 27. So if we're going to do electron configuration for 27, I'll go back to this hotel that I happen to have copied. And we'll make it big. 27. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. The way we would write that would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. All right, so the way to write the chemical or the electron configuration using the shortcut method, we would start with cobalt, go to the period above it and to the end where we see argon, and we can use that as our shortcut. So we can say AR 4s2 3d7. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. And if we wanted to write it shorthand, argon 4s2, 3d7. Now, it asks about unpaired electrons. If we go back to the drawing I just made, how many unpaired electrons are in this group? And we can see that there are 3. So the answer for that one would be 3 unpaired. Now, 67, backtracking, we're going to do the electron configuration for sulfur. Sulfur has 16 protons, so it'll have 16 electrons. 1s2, 2s2, 2p6, that's 10, 3s2, that's 12, 3p4, that's 16. Now, this would be for sulfur that's neutral. However, if we have a sulfur ions are in the oxygen family. They have a -2 charge, which means they're going to have 2 additional electrons. 2 additional electrons would be 3p6. Count the electrons: 2, 4, 6 is 10, 12, 6 is 18. 18 electrons is how many a sulfur with a -2 charge is, because that -2 is equal to protons minus electrons.